voice assistants, right? This is right now, the things that are dominating our lives, right? Our kids are now interacting with the voice assistants too. So Apple came up with this Apple Siri in 2001, and then Google came up with its own Google Now in 2012. Then Microsoft came up with Cortana in April 2014. Alexa came in, November 2014. And then Google Assistant came out in 2016. So this is like the sort of a pipeline of different types of voice assistants. What they do, now you can create a lot of different products, and we talked about some of those products previously also, that you can talk to your phone and they will record and they will convert that into semantic understanding of what you're saying, and then create different services. For example, you can ask your phone to play a different album, different songs. You can ask intelligent question, what is the weather? It will give you the weather information. You can ask them to play TV and control other things. And so this type of voice assistants are essentially enabled by RNN type of architecture, where you are taking sound frequency as an input, and then you are converting that into a sentence, and then you have a semantic understanding of what that sentence is, and that allows you to do different things. Okay, so all the different voice assistants that you see are essentially based upon the sequence-to-sequence model and have some form of RNN going on inside them to implement the technology that you see, right? One of the applications that I mentioned was, Starbucks is coming with a app where now you can speak that, I want to order this coffee with this specification, non-fat and so on. And then, you can order at the beginning of your house, and automatically the voice assistant of the Starbucks will understand it and create and keep your coffee ready, so that when you drive to that Starbucks, your coffee is already ready for you, and you do not need to input in the form of the user interface. So you do not need to select something. You can just talk and everything will be converted into a command, and then you can get your coffee. So they are working on those class of applications which are essentially going to be based on voice assistant, and this voice assistant technology is based upon the sequence-to-sequence modeling, because things are not fixed and so on, and they are essentially a class of problems where RNNs are becoming very important. So again, this sort of technology, right? The voice assistants are basically based upon what is known as automatic speech recognition, one of the aspects you need to have, and ASR in short, and that is a technology where you have a microphone. From microphone you take a user input, which is in the form of this frequency data, and then you convert that into a text, right? So taking sound as an input through microphone and converting that into a text is known as this automatic speech recognition. Here the input is sound and the output is a set of words that is coming out of this pipeline, is also a sequence-to-sequence modeling problem, and this is where RNNs are very, very widely used for this class of problem. So what goes inside ASR type of machine learning pipeline? Let's discuss that too, similar to other pipelines that we have. So essentially we have a vocal information, or the frequency information of the sound that we have, and from that frequency information what we do is, and this might be a long sequence. First what we do is we partition them. Okay, we partition a set of those information, and then we pass on a specific partition of the sound information, and we do extract features out of them. Okay, and then we have acoustic models input and the language model input that goes into the RNNs, and then the feature that has been extracted from this bit, the partition sound information, is essentially converted into a text. And we do this for all the pieces of the sound information in multiple different pieces, and we will get the words out of that. And if you connect that word, and again on that word we will use like the sequence information, like how they should be organized, and that will help us in essentially having a good language translation model based upon the voice inputs that we have collected. So this is at a very high level, what are the main components of automatic speech recognition machine learning pipeline, where RNNs are the backbone of implementing this, taking this input in the sequence form, multiple of this in a sequence form, and converting them into a sequence of word. Now, after this sequence of word, there might be other things that you might be doing, which is semantically understanding what this set of words mean. For example, if I'm speaking that I want to offer, order this coffee in a Starbucks app, right? Not only the sentence of word has to be useful, it has to be transferred into the exact specification of the coffee that I'm ordering. right? So that is the semantic understanding of what the sequence of words are. So that is also, there is another language model that does that, right? And there is another RNN type of architecture that is doing that semantic understanding of it. And so there are multiple locations in this overall pipeline of automatic speech recognition where you are using RNN as a basic architecture to do this interesting things. Okay, so with that, I will stop and thank you.